Welcome to Planet Geo, the podcast where we talk about our amazing planet, how it works, and why it matters to you. Okay, welcome to Planet Geo. Before we get into today's episode, let's recap some introductions here. You are Chris Boyce, a nationally recognized earth science teacher from the great state of Michigan, and I am Jesse Reimick, a geoscience professor at Penn State and your former student, actually. I remember maybe 15 years ago sitting in your classroom, learning about geology, learning the basics from you.
Yeah, it was more than 15 years ago. It was 18 years ago.
More than 15, but we'll ignore those. That's fine. And this is Planet Geo, where we talk about how great our planet is and how the geosciences impacts our everyday lives.
Right on. That's right. Before we get into today's episode, we ask one thing. If you take something away from this podcast, we just ask that you share it with someone that might enjoy learning about this amazing planet that we live on. Just share it.
Yeah. We've had a couple people share things on Twitter and Instagram, and it really helps a lot to get the word out. So today we are diving into water and water on Earth. Right, Chris?
Right on. We're going to talk about where the world's water is, and specifically, what are the geological basins or reservoirs that hold on to this water. We're going to get into some of the statistics of it, and we don't want to make this a statistical episode or anything like that. But we're going to throw numbers at you because they're kind of amazing, these numbers.
Yeah, they're really shocking numbers.
They are. We're going to put percentages on where the world's water is. And we're going to spend a lot of time today actually talking about the Great Lakes here, the Great Lakes Basin, only because, we're familiar with it. It's a glaring example of the problems that the world is going to face in the coming years.
So yeah, I'm excited. Let's get into it. So Chris,
okay,
where is the world's water? That's the question.
I asked this question to my students. Where is the world's water? And I have them just tell me, all right, let's organize this in no particular order. Look at the map. Where's the world's water? And so obviously you have the oceans. They come up with that. That's usually the first answer,
Okay, that's a pretty good one.
Yeah, that's pretty good. Then we can talk about glaciers. They usually will get groundwater. Lakes is up there, obviously, because we're from Michigan and we're surrounded by all these, the 5 Great Lakes.
These definitely.
Inland lakes. It's amazing. And then the atmosphere, they'll usually come to, near the end. It's not the first thing that occurs.
Takes a bit to get there.
Yeah. And then obviously rivers. Those are the 6 basins that hold the world's water. Oceans, glaciers, fresh groundwater, freshwater lakes, the atmosphere, and rivers. Okay, so Jesse, let's talk about this and quantify really where the world's water is and what does this look like in something that we can actually conceptualize.
Yeah, that's right. So in this analogy we're going to go through, we are going to treat all of Earth's water like it's a 5-gallon bucket. And for those of you who think in metric, 5-gallon bucket is, the white pail that you usually get stuff delivered in. But it's actually 19 liters or just under 19 liters. So we're going to consider all of Earth's water being in that 5-gallon bucket. That's all of Earth's water, right?
I always think of it kind of like one of those little office water jug, those
upside
upside down water jugs. That's a 5-gallon container.
All right, so let's run through some percentages. Oceans, presumably they're huge.
Yeah, presumably. Yeah, I'd say they're big.
Feels like they're about 80% of the volume.
Okay, all right. A little off on that.
Okay,
the students always say 75%-ish because the world's 3/4 water. They know that. But the question is, of all of the world's water, how much of it is in the oceans? And the answer is about 97.25%.
97%. Wow. Okay, way more than it feels like. Okay, so if we convert that in our 5-gallon bucket, it's obviously most of the 5-gallon bucket. It's most of the 19 liters in there. It's actually 18.4 liters would be ocean water. So that's a heck of a lot.
Number 2 on the list, then, we have glaciers, which has 2.1% of the world's water, which if you take these first 2 things, then we're well over 99%, and we haven't gotten to the last 4 things yet. So 2.1% of all the world's water is in glaciers. What does that look like?
Well, that looks like that's about 400 milliliters or 0.4 liters. And effectively, that's about the size of a normal beer can. A little bit bigger than a 12-ounce beer if we want to convert that way. But, consider, Yeah, it's a good one.
Yeah.
I think, it's interesting to think about the glaciers because this is where all of the water, we think about climate change and global warming. This is where the concern about sea level rise comes from is you take that beer can and you melt part of that beer can and you put it into the 5-gallon bucket, it's going to go up by a little bit. There's a significant amount of water stored in these glaciers, right?
Yeah, that's right. It's the only thing that can significantly affect, sea level is melting ice caps. It's the next most abundant source of water. All right, so number 3 on the list, groundwater, fresh groundwater we're talking about, is less than 1%. It's 0.64%. So what does that look like?
So that's 120 milliliters which is about half a cup. That's about what we're talking about. The groundwater on Earth poured into the 5-gallon bucket. Okay, now we're pretty close to 100%.
Number 4 on the list, freshwater lakes, there's 0.009%. What does that look like?
0.009. I mean, think of the massive lakes. It's really hard to comprehend coming from Michigan that it's that small.
It is very difficult.
So what this looks like is 1.7 milliliters, and that's a tough conversions, but about a third of a teaspoon. I mean, you're putting a tiny amount of water in here. You're pouring that into the 5-gallon bucket now. It's shocking coming from Michigan, and I did a lot of my PhD research up in northern Canada, where there's water everywhere and huge Great Lakes up there, and it's only that amount.
That's crazy. A third of a teaspoon on a 5-gallon scale. Okay, so number 5, atmosphere, has 0.001% of all the world's water in it.
So where's the water in the atmosphere?
We're talking about water vapor.
Water vapor. Okay, so like clouds.
Yeah, we're talking about water in the gas form. That's what we're talking about.
Okay, and what was the percentage on that again?
0.001%. So what's this look like?
0.001%. So this is 0.2 milliliters, 0.2 milliliters, which is kind of a hard conversion, but a very, very small. It's like an eyedropper kind of amount of water.
It's
tiny.
Less than 10 drops of water from a little eyedropper. And then we have, last but not least, rivers at 0.0001% of all the world's water. So,
tiny. 0.02 milliliters, 0.02 milliliters. That is less than one raindrop worth of water in the 5-gallon bucket. Yeah, I mean, it's crazy. You drive across the Mississippi or you go over one of these huge rivers. It's always flowing. You'd think, wow, there's tons of water in there. But a raindrop in a bucket, that's all the water
That's all that it is. That's all that it is. So then what's available for us out of this, right?
What can we consume?
The water that we have to use, well, we can't use the oceans significantly because it's salt water. We'd have to do things to it, and those things are expensive. We obviously can't use the glaciers, and when glaciers melt, they flow into the ocean and become salt water. So what are we left with? Of all the world's water, far less than 1% is usable for human consumption.
That's right. It's like a half of a cup of water in a 5-gallon bucket. So is there enough to go around? Like, how, what is the calculation?
Yeah, it's, that all that water can support roughly 9 billion people.
Okay. So there's obviously some slop in that calculation, but around about 9 billion people with usage rates and all that kind of stuff,
the way we're using water right now and so on. We'll talk a little bit about this in a little while, but we have 7.8 billion people on the planet. We have enough water here for 9 billion people. So why are we worried about it? Yeah,
well, it's an interesting question. Why do we face water shortages? And the answer is really that water is unevenly distributed around the globe. And some places have lots of water, some places have very little water. And what we're going to go into now is highlighting one place that has a lot of water, which is our home turf, the Great Lakes Basin. And so let's get into, the Great Lakes. When we think of the Great Lakes, what we're going to talk about is the 5 Great Lakes that are on the border of the United States and Canada, kind of in the Midwest, around Michigan, Minnesota, Ontario. There are other Great Lakes as you get up further north in northern Canada, but there's far less people living around them. So we're going to talk about the Great Lakes being, Michigan, Superior, Ontario, Huron, and Erie.
You had to think about that for a little bit. That took too long.
I got stuck on that one.
You are a piece of work, man. You do not have the right to call yourself a Michigander anymore.
I might have lost that right. Yeah, I might have lost it.
First of all, that's interesting because I have never heard that before, that there are other Great Lakes. I've never in my life heard that.
Yeah, so
I'm a little offended by it, actually.
No, yeah, there's some big Great Lakes. Actually, the Great Bear Lake and Great Slave Lake, they're number 8 and number 10 in the ranking of surface area. So these are huge lakes. They're both in the top 10 globally of freshwater lakes by surface area.
That is crazy.
Yeah, so it kind of, I mean, it's a geologically interesting. All these Great Lakes fall on the boundary between the Canadian Shield and the sedimentary basin to the south. But anyway, that's neither here nor
It's
there.
only because of you that I've ever heard of these lakes. So
Yeah.
I don't know.
Well, there
Yeah.
you go. They're
Anyway,
because they're way up north
yeah,
and very few people live near them.
right. So anyway, Jess, we got to talk a little bit about the Michigan Basin, right? So what is the Michigan Basin?
Yeah, so the Michigan Basin is basically around Michigan. All the rock layers, so there's a load of sedimentary rock layers. So these are rock layers that were laid down in an ancient ocean, and they form a basin. They're all tilted down. Think the opposite of a hill. They're tilted down so that they kind of form this basin.
It's like a big salad bowl, right?
Yeah, a big salad
Okay.
bowl, and all the layers are
A gentle dipping salad bowl, but
That's
it's
right.
all the way around. Okay.
exactly.
So- And the Great Lakes are kind of on the perimeter of this basin that we call the Michigan Basin. Okay. And so every bit of water that hits inside that basin, inside that gently dipping salad bowl, is going to go then to one of the Great Lakes. Okay. And this is like, that's why Michiganders are so stingy and get fired up about our water, because Michigan lives, and we're the only state that lives entirely within the basin.
Yeah, so real quick, the term Michigander, this is something I didn't realize until I moved out of Michigan, is that people have no idea what a person from Michigan is called. And
That's really weird.
Yeah, a Michigander, I mean, it's kind of a weird term at the end of the day. Like, it sounds like a goose or, something like that. I mean, the number of times I said, oh, I'm a Michigander, and people look at me like, what the heck are you? Like,
I'm not sure you should be called a Michigander again, because you couldn't even remember the 5 Great Lakes, you idiot.
fair point.
So, all right. Anyway, let's get into this though. Let's talk about how much water's in these Great Lakes. Okay.
Yeah, absolutely.
Well,
Massive.
I mean, just some
Massive amounts.
stats. How much water is in the Great Lakes? Well, they have 84% of the standing surface water for the North American continent. That's
For the
amazing.
North America,
84%.
that's 21% of the world's fresh water is in the 5 lakes around Michigan.
Yeah.
Crazy.
21% for the world. If you just take the United States, they have 95% of all the standing surface water in the entire U.S. 95%. And we don't have anywhere close to 95% of the population of the U.S. in this basin. Not even close. And that's what we're highlighting.
Yeah, exactly. So this water, if you kind of convert that, if you take that water in the Great Lakes, in the 5 Great Lakes, and spread it over the continental U.S., the 48 states, it'd be 9 feet deep.
Yeah.
I mean, it's
If
insane,
everything
right?
was flat, right? If everything was
Yeah.
like Nebraska flat, that is a lot.
So we have 21% of the world's fresh surface water, and there's 30 million people that live in the Great Lakes Basin. So not even close to 21% of the world's population that live near these lakes, right? So people from us Michiganders, we are rich in water, right?
We are. If we have one thing, we have water, but we do have issues. Let's transition, Jesse, and talk about what some of those issues are.
Yeah, absolutely.
Okay.
Let's do it.
I mean, this is new, what I'm going to talk about right here. This is a newer thing, but it's shocking, I think, because of the amount of water that we have. Our glacial aquifer. Okay, now, Jesse, real quick, just tell us what an aquifer is.
An aquifer is a layer underneath of the earth that contains water, that water flows through. So when you drill a well on your property, or if you're drilling a well somewhere, you're trying to tap into an aquifer, it's just a layer, it's a sediment or some layer in the earth that contains water.
Yep. So our glacial aquifer is being drained faster than it can be replenished.
Right.
Okay.
So this aquifer is full of glacial meltwater.
It is full of glacial meltwater, and it's going dry. And that's amazing. It's, because of residential wells, agricultural wells, for irrigation and things like this. And they're doing studies on the rate at which our glacial aquifer is being depleted. It's
interesting.
unbelievable.
So this is an aquifer that like everybody in the area will tap. If there's water coming out of the ground, if you're pumping water out of the ground, it's coming from probably this particular aquifer, which has glacial meltwater from 20,000 years ago or something in it, right? And so that water's been there for a long time. If we draw it out, it takes a long time to put water back into that aquifer system. So it gets recharged in that way.
Yeah, we can take the water out of the aquifer much faster than the water will replenish in a natural way. And that's a problem. And so what we have seen actually is these wells have gone dry or they've gotten too salty.
And the salty thing is interesting. So why does it get salty? As you draw it out, why does it get more salty?
Something that wells can go dry, or wells, when you get them down and they're fairly depleted, there's not a lot of water in the aquifer anymore, you start to draw salt out of the rock instead. So you get salt water instead, which is, of course, nobody wants that. So, there's a township nearby, Allendale Township. They are prohibiting then any new development to have well water. They have to subscribe to city water where they're drawing water out of the lakes.
I mean, that is an astonishing thing. In a place like Michigan, which is surrounded by, 21% of the world's fresh water, that there's a township that won't allow you to drill down into the aquifer. I mean, it's crazy.
It speaks to the problem. This is not an invented thing. We're depleting our groundwater faster than what it can replenish. And that's a problem that even we have in Michigan. So the other major issue, so not just groundwater depletion, but the other issue that we have actually speaks to the other side of it. Because we have so much water, our water here in the Great Lakes then is under demand. We're talking about diversions. People want, outside of this basin, want to divert water to avert their water needs.
Yeah,
and that's a looming problem.
Yeah, so this is a different source of water. We talked about groundwater being depleted, the aquifer system being depleted. Now we're talking about surface water. So this is the Great Lakes, the lakes themselves, water being drawn out. So there's a couple pretty interesting examples of these, one being quite old and one being a new recent development. And the first one is the Chicago River diversion.
Yeah, so the Chicago River, well, it was over 100 years ago, 1900, I think it was when it was completed.
So the Chicago River used to flow into Lake Michigan very slowly. It's a fairly short river. It's cut off from the Mississippi drainage basin by a little hill. And so it used to flow into Lake Michigan. And so all the sewage and all the pollution from Chicago, the city, flowed into Lake Michigan. Well, guess where Chicago gets its drinking water from? Well, Lake Michigan. So all this sewage is flowing out into Lake Michigan. They're pumping it back into their well system. Obviously, this is a big problem. So the solution was to change the flow of the Chicago River and actually send it to the Mississippi. So like Chicago, the city's like, oh yeah, well, I don't know, we'll just send all of our garbage and pollution down to the Mississippi. So they dug a canal and sent it down to the Mississippi. Well, guess what happens when you do that is that Lake Michigan water is now flowing out of the Chicago River down into the Mississippi, right?
Yeah, 2 billion gallons a day is flowing out of Lake Michigan down the Chicago River to the Illinois River, which is a tributary to the Mississippi River. And this was completed back in 1900. Now, there aren't many things that get a Michigander as riled up regarding water as the issue of the Chicago River. And one of the concerns, it's not just hey, you're diverting 2 billion gallons of water a day out of this, but the other, I think, more important issue is that we're connected now to the Mississippi River in a way that we weren't before. And now we have the threat of invasive species like the Asian carp.
Yeah, these are these ridiculous things you see on YouTube videos, right? Of the fish jumping out of the air, all boats driving past, smacking people in the face.
It's a real thing.
I think they have these electric nets in the Chicago River to prevent the fish from swimming up the Mississippi, up into the Chicago River, and then eventually into the Great Lakes.
Yeah,
is that right?
Yeah. This is a really big concern, actually. The Asian carp get into the Great Lakes. They just eat everything. And so it would change. This is Michigan's number one ecological concern is this invasive species.
Right. Yeah. And there was a report last year that the Illinois Department of Natural Resources found Asian carp DNA in the Chicago River upstream of towards Lake Michigan, rather, from these barriers. So it's an ongoing concern, but it just kind of highlights this diversion of water, which occurred in 1900, but still really, really impacts the region.
And then let's transition into the Waukesha Diversion. So there's a city in Wisconsin called Waukesha. And they have a real problem. They have radium in their water, in their groundwater. Okay, now they're just outside of the Great Lakes Basin, and so they applied for permission to divert water out of the Great
So,
Lakes.
so that means they're just outside the Great Lakes Basin. So water falling in Waukesha does not flow into the Great Lakes. It flows into the Mississippi, presumably,
Yep.
and that. Yeah.
Yes,
Okay.
correct.
So they're outside of this. They don't really have a say in what goes on with the Great Lakes water supply, but they want to draw some water because their water's
Right.
bad.
Which is interesting too, because from parts of Waukesha, you can see Lake Michigan.
Oh,
They're
really
that
interesting.
close.
Okay.
Yeah, they're
Okay.
that close. So anyway, they have a real problem because the radium in their groundwater. And so this was actually the first time that the state of Michigan and the people that are in charge of, allocating this voted in favor of allowing Waukesha to take Great Lakes water from the Great Lakes Basin.
So the Great Lakes, area voted to allow them to draw water out of their basin.
Right. Yeah. They're going to take 8.2 million gallons a day and use it for their municipal water.
Yeah, interesting. Okay,
It
so
is.
let's like back up and look at the big picture here. I'm curious how these decisions kind of get made, right? We're dealing with a place that's really rich in surface water. How do we balance like the decision-making process here?
Yeah.
Can you speak to that a little bit,
I
Chris?
can. So there's a what's called the Great Lakes Water Compact, and it involves 8 states that are either in the basin or partially in the basin. So it involves obviously Michigan, Minnesota, Wisconsin, Illinois, Indiana, Ohio, Pennsylvania, and New York.
Oh, interesting.
And then it also
Okay.
involves 2 provinces in Canada, Quebec and Ontario. Anyway, the way we entered into this compact, all these states did, because we kind of see the writing on the wall that there's going to be pressure down the line because of this looming kind of crisis that we have, where there's going to be increased pressure to divert water. And some of these diversions are from a long ways away. We're talking about in the Southwest, and they want to get really creative in diverting Great Lakes water. We obviously don't want that to happen. And this is going to be challenged in the courts at some point. And we figure, I think everybody figures that, 8 states and Canada stands a better chance together than they do, alone.
Yeah, that's right. I mean, so the other thing is just think about the Chicago River, scenario. So Ontario, a province in Canada, they're susceptible to these invasive species that could make their way into the Great Lakes ecosystem, all because some engineers in the city of Chicago in 1900 decided to reverse the flow, right? So this shared decision making is kind of important and potentially a pain in the ass to get things approved, but it's pretty important to consider because everybody has a shared resource here.
Yeah, that's true. Water is a necessity for life. And this is a very complicated issue. This isn't something to be taken lightly.
Yeah, that's right. So a place like Waukesha that has, a kind of a dire need for water, they need it, and the resource is right there. And so they should be able to have a little bit. But let's talk about the decision-making process here. Like, if the question is how much water can be diverted without permanently damaging the water supply in the region.
Yeah, this is the question that I ask. Before you weigh in on whether or not we should divert water out of the Great Lakes Basin, what do you want to know? What should the citizenry want to know about this, right? And you often hear, well, how are they going to pay for it? And, are they going to treat the water, return the water? And those are all really good questions, And that's something with Waukesha too, is that they're going to use the water, but they're going to treat it and return it. To me, the most important question to ask is, well, how much water can be diverted without permanently affecting lake levels? And what I'm saying is that, how much of that water is replenishable and how much of it is there because of glacial meltwater? That's the number that I think is important.
Yeah, so by replenishable, you mean stuff that gets added to the system by rain. So there's a lot of water that's sitting there that was formed when the glaciers melted during the last ice age. The glaciers melted, filled in this basin with a lot of water. And so what's being replenished? What's being added due to just rain, effectively rain and snow melt over the course of the year?
Yeah. So 99% of the water in the Great Lakes is there from glacial meltwaut. So
wow,
means
that's a ton.
only one. I know, it's unbelievable. And
Wow.
that means 1% of it then is, replenishable. So if you divert then, you go beyond that 1% threshold that's replenishable, it's hard to walk that back. You can't undivert water. You can't stop. Once you say to Waukesha, yeah, you can have 8.2 million gallons of water a day, or, we got 2 billion gallons of water going out the Chicago River. It's hard to stop that. So once you go beyond that 1% tipping point, then you can permanently affect lake levels. And so, and we're 1% of the volume of the Great Lakes water. That's a lot of water.
It's just a ton of water.
The Great Lakes have a lot of water.
It's a serious amount of water. Yeah. I mean, just think of all the rainstorms, all the thunderstorms, all the snow that's being melted into the system in a given year. That's still only 1% of the system. So it's a lot of water. But once you go past that 1%, then you're starting to pull out, water that is 25,000 years old or 20,000 years old. And that's not coming back anytime soon. So
so those are a couple of the issues that Michigan's and the rest of the Great Lakes states and Canada are going to have to wrestle with. Well, Jesse, though, what about water issues outside of the Great Lakes Basin? What are we talking about in terms of water issues moving forward?
Yeah, I mean, I think it's a huge issue. There are big time problems in many places. In Arizona and places like this, you have whole residential complexes where water is being trucked in, like literally being trucked in on a weekly basis, that you're paying for this water. So, and I tell this to my intro level geoscience class, big, lecture of 200 students, that hydrology, or the study of water, is really a good field to be going into. This is a growing problem. It's only going to get worse as the world population increases, and the distribution of water is still going to be unfair. The Great Lakes are always going to have more water than Arizona or New Mexico, so we're going to have to deal with these problems. And the American Geosciences Institute every couple years goes through this exercise of predicting what the job market is going to look like several years out in advance. And they predicted that hydrology jobs, or groundwater related jobs, will grow at a rate of about 4.3%. And that was compared to the broader U.S. economy, which is expected to grow at like 3.5 or 3.7%. So hydrology jobs are growing at a faster clip potentially than the broader U.S. workforce. Okay, so Chris, let's kind of tie this all together, like with the question of how do humans use water? Like, if there are issues on the horizon for water resources, where do we spend our water?
Most of our water consumption comes from not what we use on a day-to-day basis for drinking and doing laundry and dishes. Most of our water consumption comes from what we eat. So let's talk a little bit about that. Let's go into some statistics about, how much water does it take to grow the food that we eat? And I want to start off by saying, these numbers fluctuate. These are ballpark numbers, but they're still startling nonetheless. So, for instance, it takes 240 gallons of water to produce one loaf of bread. That's amazing.
All right, a small soda or pop or cola, whatever you call it.
Yeah, by the way, I think you and I are the odd ones because we call soda pop. I think the rest of the world would call it a soda.
If we want to be welcoming, and if you call it cola, that's fine. But it requires 46 gallons of water to produce one 12-ounce can of soda or cola.
46 gallons.
Whew, steep.
That's amazing. Yeah, so it takes 12 gallons of water to produce a small serving of potato chips, which I don't know what a small serving of potato chips is because I can't eat that.
No, it's a bag or nothing at all, right? That's the way it goes.
Doritos, gone.
Yeah, you're a famous Dorito consumer. So to brew a gallon of tea, it takes 108 gallons of water, which that's surprising because you'd think, these are just tiny tea leaves that you steep in some water, right? But no, it takes 108 gallons of water to grow that tea. Amazing.
And this one hurts my heart, the next one,
man.
because I'm really guilty of this. To brew a gallon of coffee, okay, which is about what I consume a day, it takes over 1,000 gallons of water to make that coffee come to fruition.
Oh man, that amazing. Hurts. That is a very steep one there. Oh man.
But we have better news on the horizon. Let's hit it.
Better news. A gallon of wine only requires 872 gallons of water to produce. So wine is cheaper in water than coffee. So that's interesting.
That is interesting. A gallon of beer. Okay, a gallon of beer, which is it's like about 10 to 12 beers. Okay, takes 296 gallons of water to make.
Oh man, so okay, drink beer, not wine. I guess that's something.
Right.
So your 12
Yeah.
ounce can of beer takes 28 gallons to make. For those of you in the metric system, 12 ounces is around about 350 milliliters, and 28 gallons is round about 112 liters of water.
I was thinking about that because I make beer, right? And it doesn't take
Oh,
that much.
you make really good beer.
I do.
The main thing I miss about Michigan is drinking Chris Bullheye's beer, I think.
Yeah, everybody's got to be good at something. I'm good at making beer.
That is true.
But you have to consider though the water it takes to grow all the grain and the malt that's used in making beer and the hops and things like that, which are thirsty. So yeah, okay. And lastly, a pound of burger, and this one hurts a lot, takes about 1,600 gallons of water to make.
1,600
That's
gallons.
a lot. That is
Wow.
thirsty
That
food.
is
Yep.
that's a depressing statistic right there. Yeah.
It is.
Because that
It
goes
is.
into the feed for the cattle, what the cattle are drinking, all the stuff that
Yep.
goes into that pound
all
of
the way to
burger.
production. All the way to production. Yep.
1,600 gallons of water. That's worth highlighting again. A pound of burger requires 1,600 gallons of water to produce. That is a steep price.
Amazing.
Well, with that, I think get a geoscience degree. Go learn about water. Pay attention to
That's
water.
right.
It's a growing thing. It's going to be a looming problem, and it's worthwhile knowing something about the water resources in your area and in the area that you have a say. So
Yeah. So we thank you all for tuning in. And I just want to emphasize again that we absolutely love feedback.
Yeah, totally.
And so if you can hit us up.
yeah, hit us up. Hit us up at all the social medias. We are at Planet Geocast. If you like what you're listening to here, give us a like and a subscribe. And leave us a review on your podcast server. And also remember, we're going to be doing the Geo Shorts, answering your questions. So send those our way as well.
Yeah.
Take care.